This is this part. Let me erase this so I can explain to you what to do here. So what you need to do is write an equation for Marcus and Josue. They're both decided they wanted to see how much money they save in one semester by placing part of their earning each week into a saving account. Marcus currently has $120 in his account. So Marcus is 120 plus, Ann is plus. Plan to save $18 each. Each means time times number of weeks. Josue currently has $64 in his savings account. So $64 and Ann mean plus. Plan to save $25 each. Each means times of number of weeks, because here's the word week here. Write both equation for Marcus and Josue. Okay, let's look at Marcus here. Marcus is $120 plus 18 weeks, for X we want to X equals to the number of weeks. That together, we add those two things together, we get Y. Y is the total amount saved. Total saved. Okay, down here, look, it says savings in dollars. So Y is savings in dollars. Okay, X is time in weeks. They have X in there. If you look at here, they already tell you what time is time in weeks. That's what we need to put X as. Okay, this is how you do it. You do it like today in class. X is times in weeks. Okay, so Marcus and then Josue. Josue is $64 plus 25x equals to Y. X is the number of weeks, and then Y is total money and savings. So the only thing you can do here, so you know what to do. We know that this is because these are all over 1, so it's best to number the number of weeks. Remember the denominator, the run is weeks. These are Y's. Your slope is 18. What does the slope of the graph represent? Slope of $18 in 1 week. 18 over 1 represents $18 in 1 week. Represents savings for Marcus. Represents saving for Marcus. For Marcus. The saving represents savings for Marcus is $18 each week. So that means $18 is, these are the dollars amount, that's Y, and this is the number of weeks. So notice weeks is 1, same thing as Josue. Josue is $25 here. So he saves $25 each week for also number 1. So for number of weeks, we count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20. Okay? Now, and then the Y's. The Y's here is the hard part because we got the y-intercept of, what does the y-intercept of? Y-intercept of 120, which represents the starting savings for Marcus at 0 weeks. Savings for Marcus at 0 weeks. y-intercept at 0, 20 or 0. Okay, so, and then $64 is Josue. The only way you can graph this is you pick points. Okay. Pick points for both Josue and Marcus. Alrighty. So we know these lines will intersect somewhere because the slope, the rate of change are different. So you need to find the intersection when they are the same, because it's asking for what does the solution represents. Okay, so we need to find where they may intersect. We're going to estimate, okay? So we put 0, x is 0 for Marcus. This is Marcus' graph. X is 0, y-intercept is at 120. Let's choose 20 here, our largest point. Just like the other homework assignment, if we choose 20, 120 plus 18 times 20, okay, is equal to, let's see, our coordinates for that. I need my calculator. I should have it out. 18 times 20 is 360. Actually, let me make sure though. Sometimes, as you can tell, I do things in my head. 18 times 20 is 360. So 0, 120, 360. So we got 480. Okay, so my ordered pair for Marcus, I'm going to put 0, 120, and 20, 480. Let's do Josue. Josue, X, that X represents the number of weeks. At 0 weeks, Josue have saved $64. That's the y-intercept. Okay, so Josue is 0, 64. The other one is 20. So if we input 20, we got 64 plus 25 times 20. That gives you $500, right? Plus 64. So Josue is 20 at 564. All right, so those are our two numbers. So we can count by possibly 25 each, because we want to go to this amount. So by 25 each, let's see if it fits in that. 25, 50, 75, 100, 125, 150, 175, 200, 250, 300, 350 for every other one. Each one, though, represents 25. 375, 400, 475, 500. Oh, sorry. Got it wrong here. 350, 400 here, 450 here, and 500 here. We can just estimate where 564 is, okay? So we use these two ordered pairs to graph our graph, okay? So that's 0, 120. Here's 125, 0, 120 is probably here. And then 20, 480. 20 all the way up to 480, close to 475. 480 is somewhere there. That's our two dots. We can connect those two dots together. Therefore, that is our graph. Sketch the graph, okay? Now, if you look at this, the rate of change is 18 over 1. It's about 18 over 1. 18 over 1, somewhere around like that. It should be close to it, but all we need is two ordered pairs. 3 would be best, but let's keep it at 2. 0, 64. 0, 64, here's 75. 64 is somewhere there. We'll use black, so it's different than the other one. And then the last coordinate is 20, 564. 550 is right here, so a little bit above it. So somewhere there in the work. Okay, and then you connect the two dots as best you can. Get a ruler. Straighter you get, off. So it meets somewhere here. About 13 and 360 something. So the solution represents when they, what does the solution of the two graph represents? The solution of about, we're estimating here, we're putting the word about. So about 13 and 360. About 13 weeks and $360. It's the side here. Represents the time it takes. Represents 13 weeks. Both Marcus and Josue saves the same amount of about. Save the same amount of about $360. Okay, we're estimating. We can guess and check like we have in the past, but we don't have time. Now, problem 3, I started out for you guys here. Same type of problem, but the trick here is Josue, Eric, we're using Eric here. Here's Eric. Is saving the same amount as Josue at $25 per week. That's this one here. He started out with $25 in his saving account. That's him. We want to compare, write a linear system that shows that the total amount of money that's saved by Eric and Josue. So this is Eric and here's Josue, which we copied from up there. Okay, we know that these two lines are going to be parallel because notice, instead of W we use X, right, for the number of weeks. So instead of W we use X for the number of weeks. We know that these two are going to be parallel. Notice those are the same. The coefficient, in this case the slope, are the same. The lines will be parallel because the slope are the same. These are no longer called coefficient, they're slope because it relates to graph. Slope are the same. Okay, and the y-intercept, look at the y-intercept. See that? These guys are different. They're 4. And the y-intercept are different. Okay, there we go. Create a graph of linear system of coordinates shown. Answer the question. Okay, well, we know what to go by. Just the same graph as the other one. We know Josue's graph right here. We'll use Josue's graph. 0, 64. 0, 64 was about here. Okay. Oh, the only thing I forgot here is to put Josue and then Marcus. Okay, so Josue is 0, 64 and then 20, 540, right, 560, was it 564? Right up here. I was looking for this one here. Josue's coordinate, 20, 564. 20, 564, 550, 564 is about somewhere there. Connect the dots. Uh-oh, that's Josue. Okay, now, Eric goes at 25. He's right here. That's Eric. This is Josue. Eric is at 25 and go up 25 over 1. Oh, that's easy. 25 over 1, 25 over 1, 25. These are ones. Look, see how the lines never meet? They're parallel. We're good at 25 over 1 because each represents 25 over 1, 25 over 1. Even though it looks like 1 over 1, but on our y, we're going up 25. This is 25, 50, 75. Look at how parallel this is. They never meet. All we needed was, that's how I know Josue line is correct. See how all we needed was two they should never meet. This one then is a little bit off. Let's make it parallel to the blue dots. So it never meets. Okay? 25 over 1. There we go. The two lines never meet. What does the slope of it represent? The amount they save. Same as what is the same for both Eric and Josue? The slope is the same. The rate of change, I want you to use the word rate of change. The rate of change are the same. What's different? The y-intercept. We explained it here. All here. What can you include about the slope of parallel lines? When they're the same, they never meet. What is the point of intersection in this system of equation? There is no intersection. No intersection because the lines are parallel. The slope of parallel lines are the same. The slope of parallel lines are the same. The slope of parallel lines are the same. No. Will they ever have the same amount of money in their savings account? No, they'll never have. No, they will not. Never. Because the line never cross. Okay, describe the graph that has no solution. Describe the graph of system linear case. The graph is parallel. No. Oh, describe the graph of a system linear that has one solution. Oh, one solution. The line crosses. One solution graph. The line cross each other, or intersect is a better word. The line intersect. One solution graph, the line intersect. Describe the graph in a system of linear equation that has no solution. No solution, the lines never meet. They're parallel. The lines never meet. Okay? Consider the system of equations. So here it is. Graph. What can we predict will happen to the graph? Let's do 3x plus 6. Oh, it's the same. You noticed? Can you predict what will happen to the two lines? They are the same lines. one on top of another. So the answer is infinite solution. They always meet. Okay, so you graph 6 right here, up 3 over 3. I'm graphing this one, up 3 over 1. Sorry, the slope is 3 over 1. The rate of change is 0.6. Okay, and you run out of room, you go the other way. If a solution is where they meet, in this case, if you graph the other line, they meet at every single spot. They meet at every single spot, therefore infinite solution. So in every spot they meet. Use substitution to prove it. Okay, let's use substitution. You put this in where this y is, right there. So you get 3 parentheses x plus 2 equals to 3x plus 6. So you get 3x plus 6 equals to 3x plus 6 minus 3x minus 3x. 6 equals to 6. Okay, so that's infinite solution.